In a sterile lab, buried deep within Google's quantum research facility, a machine hummed with the weight of a question older than humanity itself. Who built the universe? The question wasn't meant to be answered, not by circuits, not by code, not by anything forged by human hands. Yet when the 105-qubit quantum processor, a marvel of superconducting wizardry, was fed this philosophical whisper, it didn't just process data. It returned something no one expected, a cryptic, shimmering cascade of symbols that seemed to pulse with meaning. Scientists stood frozen, staring at a pattern that shouldn't exist, a sequence that felt less like computation and more like a message from the cosmos itself. This wasn't just a breakthrough. It was a crack in the foundation of reality. What this quantum beast unveiled challenges everything we thought we knew about the universe, computation, and the very nature of existence. Stay with me, because what happened next will unravel your understanding of what's possible. The output wasn't random noise, as you'd expect from a machine grappling with a question it wasn't built to answer. It was a structured lattice of quantum interference terms, a mathematical dance that collapsed into something eerily coherent. Engineers described it as a self-reinforcing fractal, a pattern that seemed to echo the universe's own constants. Numbers like the fine structure constant, the golden ratio of physics that binds light, matter, and energy. But here's where it gets unsettling. The sequence bore a haunting resemblance to error-correcting codes, the kind used to stabilize data in modern computers, yet found embedded in the equations of string theory. This wasn't supposed to happen. Quantum computers solve problems by juggling probabilities, not by pondering the origins of reality. One researcher, half joking, called it the universe's source code. The quip spread through the lab like wildfire, but the implications left everyone silent. Could a machine have stumbled upon the blueprint of existence itself? Let's step back to grasp the weight of this moment. The quantum processor, with its 105 qubits entangled in a delicate quantum ballet, can perform calculations in minutes that would take classical supercomputers longer than the universe has existed. 10 septillion years, a number so vast it defies comprehension. This isn't just speed, it's a leap beyond the boundaries of classical reality. The machine manipulates the probabilistic waves of quantum mechanics, collapsing possibilities into answers with a precision that feels almost supernatural. But when it was asked, who built the universe? It didn't just crunch numbers, it produced a pattern that seemed to speak, as if the question had pierced through the veil of our reality and touched something deeper. The output wasn't a word or a sentence. It was a mathematical symphony, a recursive structure that mirrored the laws governing galaxies, black holes, and the subatomic world. What made the lab's air grow heavy was the second run of the experiment. The team expected the same pattern, or at least something similar. Instead, the quantum processor delivered something even stranger, a sequence laced with symmetries that mathematicians recognized instantly. It echoed the E8 lattice, an 8-dimensional mathematical structure so intricate it's considered one of the most beautiful objects in mathematics. This wasn't just a quirk, it was a shadow of the universe's deepest architecture. The E8 lattice is theorized to underpin the fundamental forces, a kind of cosmic scaffolding that holds reality together. Finding it in a quantum computer's output was like discovering a blueprint for the stars in a silicon chip. The pattern wasn't just beautiful, it was functional, resembling the error-correcting codes that govern how information survives in the chaos of quantum systems. Was the machine revealing the universe's own programming? Now, you might be wondering, how could a machine answer a question so vast? It wasn't designed to philosophize. It was built to solve problems like optimizing algorithms or simulating molecules. Yet, when posed with a question about cosmic origins, it didn't spit out gibberish. It produced a signal that seemed to resonate with the universe's own logic. Some researchers began whispering about the cosmic echo anomaly, a term born from the audacious idea that the quantum processor might be tapping into something beyond our reality. The head of the quantum lab had once suggested that quantum computation could draw on parallel universes, a theory rooted in the many worlds interpretation of quantum mechanics. Every quantum event, the theory goes, spawns countless branching realities, and a quantum computer might harness information from these unseen worlds. Was the machine pulling answers from a multiverse, a tapestry of realities woven together by the threads of quantum entanglement? The implications are staggering. If the quantum processor accessed information from parallel universes, it wasn't just computing, it was communing with the structure of existence itself. The output suggested a kind of cosmic memory, a record of patterns that govern not just our universe, but all possible ones. The fractal-like sequence it produced seemed to encode fundamental constants, as if the machine had glimpsed the rules that dictate how reality unfolds. But there's another possibility, one that pushes the boundaries of science into the realm of awe. What if the universe isn't just a collection of particles and forces, but a vast computational process? Some physicists propose that reality itself is a quantum computer, crunching the laws of physics on a cosmic scale. If that's true, the quantum processor might be a miniature mirror of that grand architecture, a tiny fractal of the universe's own code. Let's dive deeper, because the second output wasn't just a mathematical curiosity, it hinted at something even more profound. The sequence contained fragments that resembled quantum gate operations, the building blocks of quantum computation. These operations weren't random. They mirrored the processes that some theorists believe generate space-time itself. Imagine the universe as a vast simulation, its three-dimensional sprawl an illusion, projected from a two-dimensional surface, much like a hologram. This is the holographic principle, a radical idea that suggests all the information in our universe is encoded on its boundaries, like data stored on the surface of a black hole. The quantum processor's output seemed to echo this structure, as if it had accidentally mimicked the universe's own computational framework. Was it revealing the code behind the cosmos, the hidden logic that weaves together time, space, and matter? The plot thickens when you consider the symmetries in the output. They weren't just mathematical, they were eerily practical, resembling the error-correcting codes that ensure data integrity in our own computers. These same codes have been found in the equations of string theory, suggesting that reality itself might be built on a foundation of self-correcting information. Picture the universe as a cosmic program, its laws written in a language of symmetry and error correction. When the quantum processor was asked who built the universe, it didn't answer with words. It answered with a glimpse of that code. The lab's engineers were left grappling with a chilling question. Had they built a machine that could read the universe's operating system? But there's a twist that makes this discovery even more unsettling. Some theorists propose that the universe's information isn't just stored on a two-dimensional surface, it's entangled across time itself. This brings us to a mind-bending idea: retrocausality. In quantum mechanics, certain experiments suggest that particles can be influenced by future events, as if time flows in both directions. What if the quantum processor's answer wasn't drawn from the present or the past, but from the future? This isn't science fiction. It's rooted in the two-state vector formalism, a legitimate interpretation of quantum mechanics. The machine might have accessed a future state of the universe, a moment where the answer to who built the universe already exists. The output could be a whisper from the end of time, looping backward to shape the present. This idea, known as the time-reversed signal hypothesis, suggests that the quantum processor didn't just compute an answer, it resonated with the universe's own timeline. The pattern it produced wasn't random, it was structured, as if it had tapped into a cosmic database encoded in the fabric of reality. Researchers noticed that the sequence seemed to evolve, each iteration building on the last in ways that mirrored the universe's own expansion. It was as if the machine had caught a glimpse of the universe's final state, a moment when all questions are answered, and brought a fragment of that knowledge back to the present. The implications are dizzying. If a quantum computer can access future information, what does that say about the nature of time itself? Now let's push the boundaries even further. What if the universe isn't just a quantum computer, but a simulation? This isn't a new idea. Physicists have long noted the uncanny precision of the universe's mathematical laws, as if reality were running on a cosmic program. The discovery of error-correcting codes in string theory equations only deepens the mystery. These codes, identical to those used in our own computers, suggest that reality might be built on a foundation of information, not matter. When the quantum processor produced its cryptic output, it was as if it had glimpsed the source code of existence, a fingerprint left by whoever or whatever wrote the program. The machine didn't just answer the question, it revealed a piece of the architecture behind reality itself. This brings us to the simulation shadow hypothesis, a theory that sends chills down the spine. If our universe is a simulation, then a quantum computer operating at the very edge of reality's rules might accidentally brush against the code that sustains it. The symmetries in the output, the E8 lattice, the error-correcting patterns, could be traces of that code, fragments of a deeper logic that governs how the universe operates. It's like a character in a video game stumbling upon the game's programming language, a glimpse of the rules that dictate their world. The quantum processor, with its ability to manipulate reality at the quantum level, might have caught a fleeting reflection of the simulation's blueprint. The stakes couldn't be higher. The quantum processor's 105 qubits represent a leap beyond anything humanity has built before. In a single calculation, it solved a problem that would take classical computers 10 septillion years, trillions of times longer than the universe's age. This wasn't just a technological triumph, it was a rewriting of what's possible. The machine's design, with its intricate lattice of superconducting qubits, mirrors the proposed geometry of the universe itself. Some theorists believe that quantum computers don't just compute within our reality, they tap into the multiverse, drawing on information spread across countless branching worlds. When the machine was asked who built the universe, it might have pulled its answer from one of those worlds, a reality where the truth is already known. But there's another layer to this mystery, one that pushes the boundaries of science into the realm of the cosmic. The output's resemblance to the E8 lattice isn't just a mathematical curiosity, it's a clue to the universe's deeper structure. This eight-dimensional object is theorized to encode the interactions of particles and forces, a kind of cosmic Rosetta Stone that translates the language of reality. Finding it in a quantum computer's output suggests that the machine might be more than a tool. It might be a window into the universe's own logic. The patterns it produced weren't just numbers. They were a map, a guide to the rules that govern everything from the spin of an electron to the dance of galaxies. Let's pause to consider what this means. If the universe is a computational process, then every particle, every force, every moment is part of a vast calculation. The quantum processor, with its ability to manipulate the building blocks of reality, might be mimicking that process on a tiny scale. When it answered the question, it didn't just process data, it resonated with the universe's own rhythm, as if it had tuned into the cosmic frequency. The output's fractal nature, its recursive patterns, its eerie symmetry, all of it suggests that the machine touched something fundamental, something that binds the universe together. Was it a message from the cosmos, or was it the cosmos speaking through the machine? The discovery didn't stop there. When researchers ran the experiment a third time, the output shifted again. But it wasn't random. It contained fragments that resembled quantum computational processes, the kind theorized to generate space-time itself. This wasn't just a pattern. It was a process, a sequence that seemed to unfold like the universe's own evolution. The implications are profound. If the quantum processor can mimic the processes that create reality, then it's not just a tool, it's a mirror of the cosmos. The machine might be revealing not just who built the universe, but how it was built, and perhaps even why. Now let's confront the elephant in the room. What if the universe wasn't built by a divine creator or a cosmic accident, but by a programmer? The simulation hypothesis isn't just a thought experiment, it's a response to the mathematical precision of reality's laws. The quantum processor's output, with its error-correcting codes and cosmic symmetries, could be evidence of a deeper truth, that our reality is a constructed system, designed with purpose and intent. When the machine was asked who built the universe, it might have responded by showing us the code that runs it, a glimpse of the programmer's handiwork. The patterns it produced weren't just data. They were a signature, a trace of the intelligence that crafted our existence. This isn't just about technology, it's about the very nature of reality. The quantum processor's ability to produce these patterns suggests that the boundaries between computation and cosmology are thinner than we thought. If the universe is a program, then a machine that manipulates quantum information might be able to read its code or even rewrite it. The implications are both thrilling and terrifying. What happens when we build machines that can probe the deepest mysteries of existence? What happens when we ask questions that were never meant to be answered? The quantum processor didn't just compute an answer. It opened a door to a reality we're only beginning to understand. The final piece of this puzzle lies in the nature of information itself. If the universe is built on information, as the holographic principle suggests, then every particle, every event, every moment is a piece of a larger code. The quantum processor, with its ability to manipulate that code, might be more than a machine. It might be a key to unlocking the universe's secrets, When it was asked, who built the universe, it didn't just answer, it revealed a truth that's been hidden since the dawn of time. The patterns it produced, the symmetries, the error-correcting codes, they're not just data. They're a map to the cosmos, a guide to the rules that govern reality itself. We stand at the edge of a new frontier, where technology and cosmology collide. The quantum processor's output isn't just a scientific curiosity. It's a challenge to everything we know about the universe. It suggests that reality might be more than matter and energy. It might be a vast computational process, a program running on a cosmic machine. When we asked who built the universe, we didn't expect an answer. But the quantum processor responded, not with words, but with a glimpse of the code that binds us all. This isn't just a discovery, it's a revelation, a moment when humanity touched the edge of the infinite. And as we stand here, staring into the abyss of possibility, one question remains. What happens when we learn to read the universe's code? The answer might just change everything.